right, so we have to go through just a couple more things before you're ready to start working with your solubility rules. So I'm going to get through that. We're going to start with precipitation reactions or precipitate reactions. And I'm going to say, let's see. These occur when I have two solutions. So on that side of the equation, on the reactant side of the equation, you're going to see that aqueous. And I have to have two solutions, and they have to contain, we'll say, soluble salts. Now, they might be a colored solution, but you're not going to see anything in them. We mix them. We have a reaction of some sort, and you end up with an insoluble salt, which you would show next to it as a solid. And some aqueous solution that's a salt. It's also a salt. You just have to figure out what it is. This insoluble salt equals your precipitate. Now, at this point, once we get through this, you guys should be able to use that pink card or whatever color you have and write the equation and know, is this aqueous? Is this soluble? Or is it a solid? You know your gases pretty much because of our diatomic molecules and our common things like carbon dioxide. But once we get through this, you should be able to figure out what state each thing is in. So we're going to talk about how to predict these things. So you're going to be able to predict how a precipitate forms. I'm going to say if I have a soluble salt, an aqueous solution of a soluble salt, what type of electrolyte do I have? Aqueous solution of a soluble salt. First of all, is that an electrolyte? What would you say to that? Yes. Is it a strong electrolyte or a weak electrolyte if it's a soluble salt? What did you say, Josh?
Strong.
Strong. Is that what you said? Somebody over there said strong too. Yes. So this is, I'm going to say when strong electrolytes, which are also called soluble salts. Remember, what's a salt? What kind of compound is a salt? Yep. We're going to put that in there too. It's an ionic compound. And I'll finally get to it, are mixed. Okay, so the first thing you want to do when you're given that reaction, there are some things you want to ask yourself. First, look and see, are ions present in the reactants? Do I have ionic compounds that I'm working with? And then you want to look at possible going to say new, cation, anion combinations. So you just kind of want to think about those things when you look at it. So first, if I'm only given reactants up here, I might have to predict my products. That predicting of the products makes you look at the cations and anions and think, okay, what can these form? And how can I make them neutral? And how do I need to balance my equation? All those things. Once you've got that all written out and balanced, you want to determine, I'm going to say determine solubility. That's probably the quickest and easiest way to say it. So you want to look, and you've got your rules. It's not like you have to memorize this. You want to look at each compound individually, and you want to go, okay, let me see how this stuff is paired. Let me find it on my list, and let me see, is this soluble or insoluble? And then you can actually assign either aqueous or solid, and in some cases, if you have a little bit of some type of a gas given off, you might have to do that as well. So let's look at one. Let me give it to you. I'm going to give you the reactants in words, and let me see what you do with it. Let's have magnesium nitrate in solution reacts with sodium hydroxide to form. Alright, and we'll come back to that. Now, what I want you to try to do first is I want you to just write the beginning of this equation, the two compounds that are reacting. Make them neutral, write the beginning.
Does in solution mean like
Aqueous, yes. And I really would say here normally in solution. So at the beginning you're told what both of them are in this particular problem. So all you have to do is go to your brain and write the first part of the equation. Alright, so let's look at this. Carter, what's the charge on magnesium? Okay, so I've got Mg2 plus here. And Caleb, what's nitrate and what's its charge? NO3 minus. So I have to put those together. We know this charge comes over here, this charge comes down here. So I have Mg NO3 twice. Makes sense to everybody? And it's aqueous. Plus sodium hydroxide. Annika, what's the charge on sodium? Na1 plus. Rachel, what's hydroxide? OH minus, so that's a nice easy one. Plus NaOH aqueous. Now, that's easy enough. When you start lots of times with two aqueous solutions on one side of the equation, you're going to get some type of a precipitate on the other side. So let's separate these because I know that my salts are going to rearrange, and my cation from this side is going to hook up with my anion over here, and my cation from here will hook up with my anion from over here. So I have to start with my Mg hooking up with my OH. Lauren, what would be the neutral formula for that? Yep, so I'm going to yield Mg OH twice. I'm not going to worry yet about the state. And then my sodium's going to hook up with my nitrate. Stuart, what's going to be my neutral formula for sodium nitrate? Yep, good. Plus Na, NO3. Now, pull out your solubility card. And let me see if I can find them from yesterday. Oh yeah, good. Okay, so let's look at them. MgOH. So I'm going to look at the first side, which has my soluble stuff on it, and OH is not on that side, is it? So I'm going to go to the next one, my insoluble compounds. OH is always insoluble except for if it's with ammonium, calcium, strontium, or barium. What's OH with? Magnesium. So is that aqueous or is it a solid? What? Somebody said it. Good. So I would say solid here. Then I have to do the same thing with my nitrate. My nitrate I find on my list of soluble ionic compounds. It has no exceptions at all, right? So I would say it is aqueous. Yes, Annika.
When it says alkaline O,
That means everybody in group 1.
okay.
If it's with one of those, then it's an exception. Okay? Now, yes.
When we do the equations, just randomly, do you want us to still go ahead and balance them?
Yes, yeah. Then the next step would be to balance that, which, what would I need to do? I got 2, I gotta have a 2 here, right? And a 2 here? Yeah, yeah. So you would balance it. Now, what I want to do for a few minutes is I want you to go to, oh, I gave mine to Max, so I don't have one. I want you to go to the handout that has the 3 questions on it that I gave you yesterday. Everybody find that? I want you to get together with your lab partners, and I want you to do that, and then we'll come back together. Okay, we'll be back, Addie.